rational functions are what we call complex fractions. A complex fraction is a fraction in which the numerator and or denominator both contain fractions. So I like to say it's a fraction within a fraction. Okay, it's a complex fraction. So to simplify these complex fractions, we want to rewrite it so that it's a single fraction. We don't want this fraction over a fraction. We want to be able to turn it into just a single numerator and a single denominator. So the instructions here say to create a single fraction in the numerator and in the denominator. That's not going to apply to the first few questions that we do. Then it's division, okay? Where a fraction is really just telling you to divide. So what did we do when we divided rational expressions? We flip and multiply by the reciprocal. And then we want to simplify, so we may need to factor if that applies. So like I said, the first four here, we don't have to worry about getting it as a single numerator and single denominator because it's already in that case. So in example 1 right here, all we need to worry about is, and I don't have my pen going here, sorry, forgot about that. We just need to keep the top the same and then flip the bottom one over and turn it into a multiplication problem, okay? So we're going to do that here on number 1. Keep the top the same, whenever my marker, there we go. Okay, keep the top the same, a over 2 times, flip the bottom one over, and it's multiplication, 4 over a squared. Now with problems like this, all we had to do was simplify anything that showed up in the numerator and in the denominator. So 4 over 2, we can just leave a 2 in the top. A over a squared just leaves an a in the denominator. So that is that complex fraction simplified. Okay, so let's do the same thing with number 2. Keep the top one the same. Flip the bottom one over, and it becomes multiplication. Okay, top stays the same, flip the bottom one over, and we multiply. So let's see what we can simplify. We've got 6 over 3. I'm going to try and kind of write this here so I don't get confused. That leaves us with a 2 in the numerator. X cubed over x, that means that becomes x squared in the numerator. So let's simplify what we've got. In the numerator, we have 2 times 8, so that's 16, and x squared. And in the denominator, we have y times y, so that leaves us with y squared in the denominator. Okay, so number 3. Same thing, we've got single numerators and denominators, so we keep the top one the same. We flip the bottom one over and multiply. So let's see what we can simplify. We can simplify those monomials. 18 over 4, those are both divisible by 2. So that leaves us with 9 over 2. The p over the p squared leaves us with just a p in the denominator. So let's see, we've got 4p minus 1 and 8p minus 2. Those are not exactly the same, but is there something that we can do to either one of those? We can take a GCF out of the denominator. So let's do this. Let's kind of write what we've got so far. We've got a 9 times 4p minus 1 in the numerator. Notice the 4p minus 1 needs to go in parentheses. Okay, and then in the denominator, don't lose that 2 and the p from the second denominator. And then let's factor out the 2. Okay, 2 times 4p minus 1 from the first denominator. I factored out the 2. So we can now cancel the 4p minus 1s. And we're left with 9 over 2p times 2 is 4p. If we could simplify 9 over 4, we would, but that does not simplify. So that is your final answer. So since we had to factor there on the next problem, let's go ahead and factor while we're flipping, okay? So k minus 1, can't factor that. k, we don't factor that, so keep the top the same. We multiply by the reciprocal, so k squared is now in the numerator. K squared minus 1, difference of perfect squares. K plus 1 times k minus 1. So let's see what we can cancel. We can cancel the k minus 1s. We can cancel one of those k's. So we're left with a k in the numerator and k plus 1 in the denominator. Is there anything else I can simplify? No. We're not allowed to cancel those k's right there. We're not allowed to cancel those k's. All right, so let's just practice with this idea.